Hanger diagrams. The hanger diagram shows a hanger with two sides. Each side of the hanger represents an expression in the equation. First, look at a hanger diagram that isn't balanced. Study the diagram. What can you conclude about the relationship between the square and the triangle? You can see that the square has more weight than the triangle, making the hanger unbalanced. The square is not equal to the triangle. Now look at a hanger diagram that is balanced. What must be true about the relationship between the square and the triangles? Because the hanger is balanced, you know that one square is equal to two triangles. How does this work with equations? You know that an equation shows two expressions that have the same value. This means if you represent each expression on a side of the hanger will be balanced. Let's see how to create a hanger diagram for the equation n plus 2 is equal to 5. Notice that the diagram uses a shape for the variable that is different than the one used for the constants. This helps you understand the different parts that make up an expression. The diagram shows that some amount, the variable n plus 2, has the same value as 5. You know the two sides have the same value because the diagram is balanced. When you solve an equation, you're looking for the value of the variable. On a hanger diagram, you can find the value of the variable by having just the variable by itself on one side of the diagram. How can you get the n alone? Easy, just take off the two triangles attached to it. Oh no! What happened? The hanger is no longer balanced. That's because the 5 triangles on the right side had the same value as the variable square plus 2 triangles. When the 2 triangles were removed from the left, it meant the values were no longer the same. What can you do to bring the hanger back into balance? Yes, you're right. Since you removed 2 triangles from the left side, you should do the same thing to the right side. The hanger is back in balance. By removing the same value, in this case, 2 triangles, from both sides, you kept the value of the 2 sides equal. Now you know that the square is equal to 3 triangles. Since the square is n and the triangles are each 1, that means n equals 3. Wait, that sounds a lot like the answer to an equation? Good thinking. It is. By doing the same action to both sides of the hanger diagram, you were able to solve the equation and find the value of the variable. You can check your solution, n equals 3, by substituting the value back into the original equation. Here's another equation that can be solved using a hanger diagram. 2x plus 4 equals x plus 6. This example has the variable shown on both sides of the equal sign. As you draw a hanger diagram for the equation, remember to use a shape for the variables that is different from the shape used for the constants. Once your hanger diagram is drawn, you can use it to find the value of the variable. To find the value of the variable, you need to discover what one variable square is equal to. But you have 2 variable squares on the left side and another variable square on the right. What do you think you can do? Remember that to keep the hanger balanced, whatever you do to one side, you have to do to the other side. If you take one variable square off each side, is the hanger still balanced? Yes, you have removed the same value from each side, so the hanger and equation remains equal. Now you have just one variable left, but it's still connected to the constant, 4, as shown by the 4 triangles. To get the variable alone, just remove the 4 triangles. Of course, you know that if you remove 4 triangles on the left side, you have to also remove 4 triangles from the right side. The hanger now shows that one square is the same as 2 triangles, meaning the solution to the equation is x equals 2. Substitute this value for each x in the original equation to check that the solution makes the equation true. When you check your solution, you'll know it's correct if both sides of the equation end up with an equal value. This shows that the equation is true. If you find that a solution doesn't make an equation true, you need to go back through your work and see if you can find the error. Hanger diagrams are a fun and simple way to solve equations by showing how to keep things balanced. They make tricky math problems easier to understand by turning them into a picture you can work with. Keep practicing using hanger diagrams to get better at solving equations and building your math skills.